The main topic in this case study is slope failure. Definition of slope failure is a phenomenon in which the slope collapses suddenly due to the weakness of the earth resilience under the influence of rain or an earthquake. While the challenges we face in implementing this case study are selection of the slope failure location search process in Malaysia. This is because there are many factors in the occurrence of slope failure that occur in Malaysia. Yet we are required to find out the cause of slope failure caused by water, how it's become the cause of slope failure in the case study area later. And second one, we had to make a careful analysis of the location we study with the cause of water slope failure. There are four objectives that we have set. The first is to understand the cause of slope failure. Second, for us to understand the determination of safe and stable geotechnical structure. Third, to investigate both slope and landslide stability. The final objective is to investigate potential failure mechanism. The first location of our case study was Bukit Antarabangsa Hulu-Klang Selangor is a hilly topography area with an altitude between 133 to 203 meters above sea level and is characterized by a hot and humid climate throughout the years and has an annual rainfall of 2,500 to 3,000 mm. The occurrence of slope failure at this location is due to continuous rain caused the area to become unstable and this excessive flow of water is infiltrated below the surface and made the earth material below the surface weaker, plus with unstable slope condition. And the second one, the terrain of hilly areas. Geological condition and unstable soil type also encourage the occurrence of landslide. Therefore, to prevent future slope failure at the location, the first solution we found was build a planned drainage system. It is important to allow rainwater from hill slope to flow well and directly into drain or river and the sea. And second one, planned development. The government or housing developer need to review the integrity of the land on the hillside from time to time to prevent unwanted landslide.
Case study 2. For case study 2, I would like to talk about landslide incident. The location will be in Jalan Bukit Kukus, Paya Terubang. The causes is water flows from a creek found on the slopes. Factors: first, flow from the river water near the slopes. Secondly, heavy rains in the early hours of the morning. Third time, 7:30 a.m. in the morning, flow of water found in the slopes and landslides was decreasing. And for 1:56 p.m. on Friday, 4 immigrant workers dead, 3 injured, and 5 others are feared to be still trapped in the rubble. There are 3 ways on how to avoid slope failures. Firstly, in designing slopes, the responsible engineer should be given serious attention to geological factors. And secondly, Geological Act 2008 Act 689 should be applied. And thirdly, local authorities are mandated to regulate all buildings and premises that have been developed near artificial slopes or natural slopes.
Next, I will talk about case study 3. For this slope failure is located at Simpang Pulai at section 43.9 of the FT 185 Federal Road connecting Simpang Pulai and Cameron Highlands. The cause of the slope failure at this location is due to from prolonged rain or for a long period in our country. This occurs when rainwater seeps into the soil, which weakens the suction of the soil matrix and the shear strength, which in turn weakens the stability of the slope. This decrease in slope stability was found to be due to the amount of rainfall and how long it lasts. Therefore, the solution that can be done to prevent slope failure is for the government to build a planned drainage system. A well-planned drainage system is important to allow rainwater from hill slopes to flow well and directly into drains or rivers and the sea. Water will not stagnate in an area to cause flooding. This condition can indirectly prevent the occurrence of soil erosion and landslides. The built-in drainage system can serve as a strong fortification on the hillside. A planned drainage system can also compact the soil structure on the hillside. For the evaluation, the study location we chose was Bukit Antara Bangsa Hulu Kelang Selangor, Jalan Bukit Kukus, Payaturbong, and the section 43.9 between Simpang Pulai and Cameron Highlands. The main cause of the slope failure between these three locations is rainwater that falls over a long period of time, while water flowing on the surface will always cause erosion. And the rate of erosion is higher if the soil in an area is located in a high or steep place such as in hillside. Excessive water flow will erode the soil flowers or the top layer. This happened at the case study location in Bukit Antara Bangsa Hulu Kelang Selangor, while the main cause in the second location on the slope Bukit Kukus Road is the flow of river water near the slope and heavy rain in the long run. Last, at the third location of Jalan Persekutuan, which connects Simpang Pulai and Cameron Highlands, the main cause in this location is also due to prolonged rain. The comparison between the three locations of this case study is a hilly topographic area with an altitude between 133 to 203 meters above sea level at the international hill location. The terrain of hilly areas, geological conditions, and unstable soil types also encourage the occurrence of landslides.
Conclusion. In conclusion, we have achieved the objectives for this case study. Next, we found that there are several causes of slope collapse, namely due to water or rain. This is because rain has the potential to raise groundwater level, thus causing poor water pressure. Groundwater level fluctuations have an undesirable or damaging effect on slope stability, and also soil strain and stability decreases due to lower pore water pressure. In addition, we can also conclude that the load present on the peak or hill is also one of the contributors to slope failure.
Down, down.